Hi everyone, in this screencast we're going to be going through water treatment. So thinking about how we take water from a natural environment and make it safe and clean for us to drink. So firstly we'll go through the overview, thinking about the catchment area, so where we draw water from in the environment, and the process called screening that we use to filter out debris, looking at the water storage at Karangi Dam, and then looking at the water treatment plant, which helps to adjust the quality of our drinking water, to help remove things that need to be removed and add things that needed to be added. Okay, so we're first of all going to start thinking about our catchment area for the Clarence River. Now, it's very difficult to see on this map. The green line is the border of our catchment area, but it extends all the way up towards the border and then down towards Ebor and things like that, all the way across to the coast. It's a very large area that the water that we drink can be drawn from. It makes its way into the Orara and Nimboida rivers, which is where we directly draw our water from. So we tap it from those rivers, we pump it into Karangi Dam, but it's important for us to make sure that there is a certain amount of water that continues to flow through the rivers, so that even though the amount we take out for drinking water, even though we need that it's not going to damage the environment. So there are regulations in place to make sure that a certain amount of water must flow through the river every day, and then the amount that we need can be pumped at night time into Karangi Dam. So the place that happens is at this spot, which is called Cochrane's Pool. So it's an area on the river where this pumping can occur. But as you can imagine, pumping from a river, there's all sorts of things that might end up in the drinking water if you're not careful. So we go through a process called screening, which is designed to remove large objects, particles. It stops, turtles and fish and things from making their way into the drinking water. So it's designed to remove these things prior to being stored. So it helps to improve the quality of the water that goes into the dam and therefore into the water treatment plant, because then that means it saves a hassle in the long run. And so we have a turbidity kind of meter that helps to measure the turbidity of the water in the river, and that's what then decides whether the water needs to be pumped or not. If the water is too turbid, then it will shut off automatically, and that level is set at 2 NTU. So if the water is below that level, it can then be pumped into Karangi Dam for storage. Okay, so this is a photo taken at Karangi Dam. So you can see, so this is the dam wall here. Okay, so this is a viewing area that you can stand on. Okay, the water treatment plant is down the hill to the right here, and then we've got an area here which is for some water testing. So this dam area is very large. It's designed to store the water prior to treatment. Because we've used the screening process, the water in here is already fairly good quality, but we do certain processes here that help to ensure that. It can hold 5,600 megalitres of water. For a reference point, one Olympic swimming pool holds 1 megalitre of water. So that's a very large amount of water that can be held there. In Coffs Harbour, we would tend to use 15 to 16 megalitres of water a day. So you can see that even with the water that's just in there now, that we would be able to last for a very long time, but it's to ensure in situations of drought and things like that the water supply is perfectly adequate. It's what we call an off-stream storage. So it connects to the river, but it's not actually a dam on the river itself. So there's a lot of benefits to that. It means that the river health itself is maintained, and we don't change the course of the river in doing so. It also means that we can have greater control over what water we pull from the river and the quality. And we also, at the dam, undergo a process called aeration. So that's what these kind of pontoons are there for. So we use there's lines that run along the bottom of the dam that pump in air. That helps to ensure that the water has enough oxygen in it, but it also helps to turn the layers of water over, because as you can imagine, that the top layer of water would get sunshine. It's most exposed to the atmosphere, so it would be warmest with highest levels of dissolved oxygen. But then that means that water lower down might not, and so aeration helps to ensure that the layers will mix. Okay, so then from the dam, the water makes its way down to the water treatment plant. This is a bit of an overview diagram that shows you all the processes that happen from the raw water source, which is from the dam, all the way out to the treated water that gets pumped out. So there's a number of different stages, things that are added, things that are removed, in order to make sure that the water is the highest quality possible. The water treatment plant is downhill from Karangi Dam, but it's right next to it, literally over the road. The water treatment plant was only built in 2009. Before that we actually just took the water straight from the dam and pumped it out to people's homes. The water quality was sufficient to do that at that point, but this helps to make sure that the water is even better quality, and especially if the natural water quality decreases, this can help to improve it. It also saves them doing more processes down in cleaning out the pipes, which used to happen in the town. And so all drinking water is treated by passing through this water treatment plant. Okay, so the first process that we're going to talk about is what we call flocculation or coagulation. So this is a photo of the what we call the direct air froth flotation or DAF tank in the water treatment plant that does this. So in this process, alum, which is aluminium sulfate, or in other areas like Sydney, they use iron 3 chloride, is added to the water. What it does is that the ions in that compound help to attract very fine particles of sediment that are suspended in the water. It attracts them together, it causes them to clump, to make larger particles which become more dense and are therefore easier to see and to be screened out or removed. In some places that will settle or sediment to the bottom and then is removed from the bottom. But here in Coffs Harbour, we pump air into there. We use bubbles of gas that actually floats that scum to the top where it can be skimmed off. So you can see here, so that we've got this brown area where there's scum and the clear area here where it has been removed. So continually kind of scraping it across, I think about every half an hour or so, and then that kind of takes that level off. They'll take the clean water from underneath and then follow it on to the next process. So these aggregated particles, these larger particles of clumped together sediment and ions and things, is called floc. So this process helps to remove that. So even though the water quality was very high to begin with, you can see even on that sort of scale that there's still stuff that's in there that this process helps to remove. Okay, from then we go through a process of filtration. So the water is taken from underneath the DAF tank and then it goes through some filter beds. So we start with charcoal. So this is just a diagram of the sort of process. This is not from the council. We go charcoal, sand, and then gravel. So this will help to remove any undissolved particles. Anything that was not removed in that DAF process will be blocked by this layer of filtration. So the water penetrates its way through those filter beds and then out in order to then be disinfected and fluoridated. So then we get to this process called sanitization, or disinfection. So a way that we can kill any microorganisms that may be present in the water, and to make sure that the water contains chlorine, so that then any microbes that might make their way into the water supply later on are killed. So we use two processes. We use UV light at the plant, which kills them, but anything that's arrived in there will be killed. And then we also add chlorine gas into the water to a very small proportion. But the idea is that that both of these are designed to kill microorganisms. The chlorine remains in the water for a limited distance in order to kill any microbes further down the track that UV would not kill. But the idea is that the further away from the water treatment plant you get, the chlorine levels will need to be topped up in order to make sure that someone who lives a long way away doesn't get water with a high level of microorganisms in it. After sanitization, then we now begin the process of adding in fluoride. So you can see, fluoride dosing happens as one of the final stages in the process. We add it by the addition of this chemical here, which is called hydrofluorosilicic acid, a source of 6 fluoride ions. The idea is that this is for dental health, so to help kill bacteria and help to prevent tooth decay. It's a New South Wales health guideline, and we maintain a level of between 0.9 and 1.1 parts per million. That is around about 1 milligram for every litre of drinking water. And this has helped to reduce cavities. Okay, and so then as a result of this, all the things that we've removed and the fluoride that we've added in, that we end up with clean drinking water. But in order to maintain that, make sure that it is still clean, that we have regular testing and monitoring, the Coffs Harbour laboratory in town is responsible for checking those samples at different places around town and at the dam and so on, to make sure that everything is being carefully, that everything's working as it should, and to make sure that the processes are as efficient and effective as possible. So this data is all available on the council website, so that you can have a look and see for yourself. All right, thanks very much for watching. Bye for now.